We're going to go ahead and continue section 6.3 on properties of trig functions. And the problem I want to do is similar to the one that we did in class, which for this one we're going to find the exact value for tangent of 16 pi over 3. So we're going to find what tangent of 16 pi over 3 is equal to. Instead of counting like we did on the unit circle, what we're going to do is we're going to do it algebraically. So we're going to figure out how many times does 16 pi over 3 go around that unit circle. So let's go ahead and draw our unit circle. And we can do it one of two ways. We can use the period for tangent, which is equal to pi, or we can use full revolution. So we can ask ourselves, how many full revolutions does this tangent of 16 pi over 3 go around the unit circle? So in order to do that, we're going to take 16 pi over 3 and we're going to divide it by 2 pi because 2 pi is a full revolution around the unit circle. So this is equal to 16 pi over 3 times 1 over 2 pi. If I simplify, the pi is going to cancel and you get 16 over 6, or in other words, it's going to be 8 over 3. So we're going to take the 8 divided by 3 and you're going to get 2. 3 times 2 is equal to 6. Subtract, then you get 2. So you get 2 2/3. So what this number tells me is that 16 pi over 3 goes around the unit circle twice and 2/3 of the way of another revolution. So again, that means that 16 pi over 3 is equal to 2 of these full revolutions, so 2 of these 2 pi's, plus 2/3 of another full revolution, so plus 2/3 times 2 pi. So if you simplify, you're going to get 4 pi. I'm not going to simplify, I'm just going to leave it alone because this tells me how many full revolutions it goes around, plus, and then 4/3 pi, or 4 pi over 3 in other words. So I can simplify if I wanted to, and I can say this is equal to 4 pi over 3. So this means that tangent of 16 pi over 3 is equal to tangent of 2 of these full revolutions plus 4 pi over 3. So because this goes around 2 full revolutions, we start here and then we end at that same spot once and twice, and then 2/3 of another revolution would be 4 pi over 3. So 4 pi over 3, if we wanted to think of it in terms of 6, we can rewrite that 4 pi over 3 so that we have a denominator in terms of 6. So 3 times 2 gives me a 6, 4 pi times 2 gives me an 8 pi. So we're going to go to 8 pi over 6 on the unit circle. So now on the unit circle, let's break it up into 6 pieces. This is my first, this is my second, this is my third, my fourth one, my fifth one, my sixth one. I'm going to the 8th one because it's 8 pi over 6. So this is a 7th one and this is the 8th one. So going around 8 pi over 6 would stop right here. So then this angle gives me that 8 pi over 6, or 4 pi over 3 in other words. So the points that, or the point that belongs to this angle is -1/2, negative radical 3 over 2. That means sine is equal to negative radical 3 over 2, cosine is equal to -1/2. So that means that because tangent of this angle is equal to tangent of 2 of these full revolutions plus 4 pi over 3, this is equal to tangent of 4 pi over 3. So what I'm going to do is I'm going to take the sine of 4 pi over 3 and I'm going to divide it by the cosine of 4 pi over 3. So we're using the identity tangent is equal to sine over the cosine. So this is equal to negative radical 3 over 2 over a -1/2. So if I divide these two, we're going to get back a negative radical 3. So then this would be my, positive radical 3. Negative divided by negative gives me a positive. So radical 3 would be my answer. So that's one method. Another method is to use the period for tangent. So let's call this method 2. And we're going to use that same idea. How many times does it go around within this period? So 16 pi over 3 divided by pi, because again, pi is now the period, is equal to 16 pi over 3 times 1 over pi. So this gives me back 16 over 3. Now if I divide 16 divided by 3, this gives me 4. 3 times 4 is 12. oh sorry, so 3 times 5. 16 divided by 3, this is 5, 3 times 5, 15. You subtract, you get 1, so 5 and 1/3. So this tells me that it goes 5 times around that one period and 1/3 of another period. So again, that means that 16 pi over 3 is equal to, so now what we're going to do is we're going to do something equivalent to what we did up here, but now we're going to use a period instead of using the revolution. So this is equal to 5 full of those periods, so 5 of those pi's plus 1/3 of another period, so 1/3 times pi. In other words, this would be pi over 3. So this means that tangent of 16 pi over 3 is equal to tangent of 5 pi plus 1/3 pi, or pi over 3. This is equal to tangent of pi over 3. So let's go ahead and draw our unit circle again. And for this one, we're going pi over 3. So this tells me go 5 of these pi's. So this is 1, 2, 3, 4, 5. And then technically we'd be going pi over 3 more than this. So then we'd land right here. But because we're not using this one, we're going to go ahead and use a period to make it simpler so we don't have to go and count the number of times it goes around that pi. We're going to just use this pi over 3 as a reference. So pi over 3 would be right here. So it'd be this angle here. If you notice, this angle that I came up with initially is directly across from the angle that I'm using as a reference. So if I use a tangent, or if I find the tangent of this angle, it's actually equal to the tangent of this angle here. So for pi over 3, my point is 1/2 radical 3 over 2. That means that tangent of pi over 3 is equal to sine of pi over 3 over cosine of pi over 3, which is equal to radical 3 over 2 divided by 1/2. So this is equal to radical 3. So again, we get exactly the same solution as what we got when we were using the full revolutions. So again, just to recap, in this method we were using full revolutions. We were figuring out how many times does this 16 pi over 3 go around the unit circle in full revolutions. And for this one, we were figuring out how many times does this 16 pi over 3 go around the unit circle, but in terms of its period. So how many pi's does it go around? So we said it went around 5 pi, that's 1, 2, 3, 4, and 5 again, and then plus 1/3 pi more, or pi over 3 more. That came out to be this angle here. So 16 pi over 3 is still right here, but for this method I'm using this angle of pi over 3 as a reference. Let's go ahead and find the values of all trig functions given an angle. So let's go ahead and find the exact values of all trig functions. And the first one I want to do, or the only one I'm going to do, is theta is equal to 11 pi over 4. So in order to find the exact values of all trig functions, what that means is that we're looking for sine of theta, we're looking for cosine of theta, we're looking for tangent of theta, we're looking for cosecant of theta, we're looking for secant of theta, and for cotangent of theta. So we're going to go and find all of these trig function values. So 11 pi over 4 is the same as what we did earlier in class, and we found 11 pi over 4 goes around the unit circle 1 full revolution and 3/8 of another full revolution. So then when we simplified, we were getting 2 pi plus 3 pi over 4. So this was my reference angle, 3 pi over 4. So I'm going to do exactly the same thing for this problem. I'm going to use the 3 pi over 4 as my reference angle. So we already had the unit circle for this one, or the circle, and the angle 11 pi over 4. So let's go ahead and use the same picture. So for sine, this is equal to the y value, so that's equal to radical 2 over 2. The cosine is equal to the x value, so this was negative radical 2 over 2. The tangent is equal to the sine divided by the cosine, so it's equal to radical 2 over 2 divided by negative radical 2 over 2. If we simplify, we get back a negative 1. So for cosecant of theta, this is the reciprocal of sine of theta. This is equal to 2 over radical 2, so if we wanted to rationalize, we would get 2 radical 2 over 2. We'd multiply both the numerator and denominator by radical 2, so these are two possible answers. And for secant of theta, we would get negative 2 over radical 2. Again, in other words, it would be negative of this one, negative 2 radical 2 over 2. And if we simplify, we actually get radical 2. So this actually simplifies to radical 2. Let me go ahead and simplify this. So on this one, it would be negative radical 2. For cotangent of theta, we'd find the reciprocal of negative 1 over 1. If I flip that, I'm going to get 1 over negative 1, and 1 over negative 1 is still equal to negative 1. So that means that the sine of theta is equal to radical 2 over 2, the cosine of theta is negative radical 2 over 2, the tangent of theta is equal to negative 1, cosecant of theta is 2 over radical 2, and if I rationalize and simplify, I get radical 2. For secant of theta, we get negative 2 over radical 2. If I rationalize and simplify again, I'm going to get negative radical 2. And for cotangent of theta, I'm going to get back negative 1.